All right, looks like we've got enough to start. So welcome to the third Teuthology training session. Today we're going to talk about how to develop tests and what different kinds of tests we have and stuff. Like the other sessions, feel free to ask questions at any point. It's even better if these are more interactive rather than just a presentation. So if you have any questions about anything we've already covered or anything we're talking about today, feel free to chime in. So I thought we'd start with a little discussion about what different kinds of tests exist and stuff, and when you would want to use one or another. So we've got a few different ways that you can use integration tests with stuff. In terms of simpler tests or unit tests, I won't be going over those in detail, but generally, if you can write unit tests, it's quite helpful since they're, of course, much faster to execute and much faster to get feedback from. But I'll be going over in more detail what different ways that you can use to write integration tests. So in general, there are a bunch of different ways here. One of the most common ones is writing some kind of script that runs against a Ceph cluster. And a common form these take is what we call a work unit. These live in the Ceph repository under the QA work units directory. They could be any kind of programming language, but Bash and Python are pretty common. And since they're just running these commands against the cluster, the idea is that if the script exits 0, then that's a success. And if it exits non-zero, that's a failure. And you can run these scripts against your local vStarter environment, or you can run them within Teuthology. So if you're running these in Teuthology will go ahead and clone the Ceph repository at the version that you specified and run the scripts from there. So that means it makes it easy to run the right version of the scripts in an upgraded scenario, or just make sure you're using the consistent version of the script and not getting something from master when you meant to run a Nautilus test, for example. Sometimes these scripts aren't really necessary to run tests, but sometimes we use them to add some extra logic. For example, there's a wrapper. We have a number of tests and stuff that use the GTest framework that are like integration tests using like different libraries like Librettos or LibreD, and these end up in a bunch of the binaries called starting with Ceph _test_ and then the test name. So one example where we use our work unit to provide some extra functionalities with the Librettos tests. In this work unit, instead of running each individual test serially, we're running all the test binaries in parallel and waiting for all the sub-processes to exit. So it just makes the test process that much faster. So you can see this is a typical kind of work unit. It's just a bash script which uses set -e so that the script exits with an error if any of the commands fail, and -x so that you can see what is actually being executed by the script, so that if something does fail, you can tell what led up to that point and what may have caused the failure. And when these are run by Teuthology, all of the output from these scripts ends up going to standard out and standard error and is saved in the Teuthology log. These, when the work units are run, they're always run with a fixed set of environment variables representing the Ceph version, the test directory that Teuthology has set up, and a few other options that are commonly used. You can also specify your own environment variables to pass into these scripts. For example, with the test crash script here, it uses the test directory environment variable that we saw earlier. And relies on Teuthology to set that. So this is an example of one of the work units where it doesn't really make sense to run against vstart, since it's relying on the Teuthology setup of daemons being running in a certain spot. But most of the work units don't really care about the environment that much, and can be run in vstart within vstart or in Teuthology or against any other cluster just fine. For the test crash script that we just looked at, this is the place that exists in the Rados suite. It's in the singleton subsuite of Rados, which means that the singleton subsection incorporates the kinds of tests that don't need to be run against a wide variety of configurations. So we have all of the things that you need in one YAML file with no extra combinations of other files at all. So it makes it a nice, easy example to look at, since it's all self-contained in one place. So this is kind of a typical test like this, where we first install the packages, run the cluster. In this case, we're turning off some warnings that we would normally trigger and mark as errors, but we're expecting that this test is going to cause crashes, so we're going to ignore those kinds of those warnings in this test. And then we have the work unit task running on client.0, which is the only client role we have in this particular case. And it's specifying that we're running the work unit in the Rados/test crash.sh location. These are specified as relative to the work units directory in the Ceph repository. And you can also give it just a directory name. You could say just Rados, and it would run all the scripts below that point in the tree. You can find more information about any of these kinds of tasks by looking at their documentation in the Python doc string for where they're implemented. So if you go back to the work unit task here, you can see there's a few other options that you have. You can run tests on more than one client at once. You can specify a particular version, like a tag or a SHA-1 of the work unit scripts to run. You can pass arbitrary environment variables and configure the timeout. Like by default, all these tests are run with some sort of timeout in hours. Looks like it's defaulting to 3 hours, just so that the something gets stuck, you don't hang there forever, and we exit and clean up eventually. So work units are typically quite useful because they can be run in both vstart and Teuthology environment. And it gives you a lot of flexibility in terms of how you're running a test against a Ceph cluster. The pieces that they're not as good at are things that require direct interaction with the daemons of the cluster, like changing their running states or otherwise manipulating the cluster. If you're trying to mark OSDs out or in, or remove them from the cluster or add new daemons, those are pieces that are handled within Teuthology itself. So for those kinds of situations, you'd usually want to have something that hooks into an existing Teuthology task, or perhaps write a new task to handle those kinds of test cases. Any questions so far? All right, I'll keep going. So another common case is scripts in the YAML files themselves. These are nice for short, simple tests where you maybe don't need to worry too much about running things between different software branches, and you just want to execute a few commands. So an example of this is in the CephADM upgrade suite, where we use the CephADM shell task to run these commands inside of a Ceph-based container. We're passing in the SHA-1 as an environment variable, so that we can use whatever SHA-1 we're running against in these commands. And we have a little script here that goes ahead and pulls the orchestrator upgrade status when it's finished upgrading. We go through and list out the processes just so that we have a record of what the different daemons are running and what the versions are. We get the Teuthology log, since all the standard output and standard error from these commands goes into the Teuthology log. And then we go ahead and check that the link number is exactly one version present, and that it is the expected SHA-1. So if you don't need to customize too much, if you just want to execute some commands, this is a good way to go in terms of adding a few extra commands to a suite. If you're not using CephADM, there's an exec task which executes any commands on a given host, and it follows essentially the same format as this.
One question, Josh.
Mm-hmm.
It's about there is any place where we can find templates for different, for example, in this case, it's just to execute several commands using the Ceph cluster installed with CephADM. But this is a specific test, okay? So if we are if we want to see different examples, well, there is a folder with templates or examples of the test.
There's not a specific template folder, but what I tend to do is grep through the suites directory for a given thing that I'm interested in. So if you look for all the tasks that are tests that are using a CephADM shell or using the exec task, you'll find a number of places where we're doing that.
Okay, and the list of different tasks that we can use, the documentation, where is the documentation?
Yeah, so the documentation is all in the repository itself as a doc string for each individual module. I'm going to cover that a little bit later, but in general, every task is a module in either the CephQA tasks directory or in Teuthology itself.
Yeah.
And
yeah, okay.
Yeah, so you can look through those the files in those directories to see what is available.
Okay. Okay. Thank you.
Sure.
Okay.
We can go into a little more detail on that later.
Okay.
But yeah, you'll see if you're looking through the test suites that there are different formats and different styles that are used in different places. So there's no one right way to do things. Another form of tests is the SFFS test runner form. Despite its name, this was originally created for running SFFS tests, but it runs many manager and dashboard tests these days as well. The nice thing about this is that it runs exactly the same tests in Teuthology or against your vstart cluster using this vstart runner task, which has some documentation at the top of it for how to do that locally. But it's using the Python unit test framework, and with a kind of interface, be able to talk to the cluster and control it, whether it's running in Teuthology or in vstart. So this is quite nice, since it gives you something that's very much more similar to a Python unit test type environment, but for integration tests. You'll see this in the suites where it's represented by the FFS test runner task, and you configure it to run a given module within the tasks directory, and that module will have a bunch of these tests in it. Go look at that format of those tests real quick. So this one, in fact, only has a single test, but they'll inherit from some kind of test-based class. In this case, it looks like we have an XFS tests-based class, and then this just adds some extra testing of ACLs around that. This module is quite nice because it does allow you to interact with the cluster more through these Python tests, but it doesn't support running other tasks other than what's in your Python test. So it wouldn't be so simple to add, for example, OSD thrashing, which is a separate task in Teuthology to this interface here. But that might be an interesting future project. Another kind of test is the upgrade tests. These tend to be formed mostly out of different ways of configuring Ceph and running workloads against it via relatively complicated structures in the suites themselves. Typically, these will be doing things like upgrading the cluster in parallel while running some testing workload. And you'll often see things like -x in the suite name, which means it's meant to run against whatever upgrade to whatever version you specify. So for example, if you run the Octopus X suite, you could run that against master and it would upgrade from Octopus to master. You could run it against Pacific and it would upgrade from Octopus to Pacific. You'll see with these kinds of suites, we tend to split them into different steps and number those steps. So since Teuthology is going to go through and combine the YAML files from each of these directories in order of the directory name. So 0 first, then 1, then 2, etc. So just looking at a little more depth at one of these, we tend to first just install the cluster, specifying in the first part just what roles the cluster has. This means that there's 2, 3, 4, 5 different nodes in this test. one of them has only a client, one of them has only a monitor. The rest have monitors, managers, OSDs, or just a mix of these different daemons. In the past, we had to separate these out a bit when we were doing upgrades in a packaged environment, so that we could easily upgrade one host but not another one. For example, we needed the client to be on a separate host that we could run the older version of the client against the upgraded cluster. With SFADM, that is no longer an issue, since of course all the daemons are running in containers, so the version on the host doesn't matter. Then we tend to do basic install of the cluster, just setting things up before we upgrade, and installing the packages, in this case, running the cluster with some extra configurations, and making sure that we're all set up as an Octopus baseline kind of cluster. And getting ready for further testing by also adding an RGW daemon to the cluster we can run tests against later. You notice a lot of these upgrade suites also have the print task included, which just adds just line to the log at that point, so you can more easily see which section of the test you're in when you're examining the log. So the more interesting part happens next in the actual upgrade. So here we're running the install.upgrade task, which upgrades the packages on each of the nodes running monitor A, B, and C. But it doesn't do anything with the daemons yet until we go ahead and use the sep.restart task to restart the daemons with those new versions of the binaries. We tell it to restart a whole bunch of these daemons, but not all of them. You'll notice that we're missing the third manager, and we're missing, or the third monitor, and we're missing a bunch of the OSDs. So the idea is to induce a situation where we have part of the cluster upgraded and part not upgraded, and then run against a bunch of workloads against that. The next step is running a whole bunch of workloads while crashing the cluster. So we have this parallel task, which in this case is only running one thing, but this is a common kind of format we use in upgrade suites where we will often run more than one thing in parallel. So that's why I think this is stuck around. And you'll see this references an arbitrary label that you would put somewhere else in your YAML files. So in this case, it happens to be in this same YAML file, but we could be adding additional tasks to the stress tasks list in later files as well. We started out with just using the thrash OSDs task, which runs in the background and makes a whole bunch of changes to the cluster, like taking OSDs up and down. Maybe in this case, we're disabling the object store tool test, so we're not running those, but otherwise we would be doing things to the OSDs, like exporting PGs from one and importing them to another, or it might be increasing and decreasing the number of PGs in the cluster, changing the fullness settings so that the cluster thinks it's full when it's 50% full or 10% full, that kind of thing. Just trying to stress the cluster in general. We look at the next section. So here we are adding more tasks to this stress tasks label. That means that these are all going to be running against this the cluster when it's in this mixed state of partially upgraded while this thrashing OSDs is going on. So here we're just running a bunch of Rados benches to provide some write load against the cluster. And then we have a bunch of different kinds of workloads we're adding to test the correctness. Here we're again adding to the stress tasks label, and we're going to run the test CLS RBD work unit from the Octopus branch. Since we're still running a bunch of Octopus OSDs, we want to make sure we're running a version of the test that's compatible with those older OSDs. And you'll see that this part of the suite has a file name plus in it. This means that every one of these YAML files will be added to the test to each test. So when the suites are constructed, all of these will be concatenated together. And although GitHub is showing the directories separately, if you're listing things in less graphical order, you'll see 5, 6, and 7. 4, you see 8. So we have after all those different kinds of tests are done, and when the cluster's in mixed mode, we go ahead and finish the upgrading the rest of the daemons. So we upgrade the packages on the nodes that weren't upgraded yet, the ones running OD8 and client.0, and then restart the remaining daemons that we haven't upgraded before. We finish off the upgrade with this is actually a symlink. GitHub doesn't show this very well, but a symlink to the QA directory where we have some common files that we use across different suites. So if we go to the file it's referencing, QA releases specific.yaml, we'll see this is setting the cluster up now that it's been fully upgraded to require specific OSDs and require specific clients. This is the final step in completing the upgrade. And then after this point, we just wait for the cluster to become healthy. This is a bit of a leftover from earlier versions where when we didn't have Messenger v2 enabled by default. So we were after the upgrade is complete, we can finally enable Messenger v2 and turn off the warning about it. And then finally, after the cluster's all upgraded, then we've fully completed all the changes we want to make to it. We run a few more correctness tests at the end to verify that it's still functioning properly. So that's one example of an upgrade suite. There's a few other formats. That one was called a stress split upgrade suite, which is one of the common ones where the cluster is purposely left in a partially upgraded state for a long time while we were running a bunch of workloads. The parallel version of the upgrade suites does this less deterministically, where it's upgrading different daemons and running workloads at the same time, and not intentionally leaving the cluster stuck in partial upgraded state. But it's focused more on testing things like upgrading the daemons in different orders to make sure that doesn't have an impact on correctness. So that's kind of a brief look at the upgrade suites. Any questions on that or anything else?
Josh, in the previous directory, I saw that there were some YAML files numbered 0, 1, and 1 which was not numbered. So the numbered ones are sequentially executed and the not numbered ones are picked up randomly. Is that so? Or
They're all picked up in lexicographic order. So
okay.
In this case, I think these ones are doing things like adding some configuration parameters that don't need to be included at any particular time. So that's why they're not in a numbered list. These are all siblings, so that they're not being shown by GitHub, but they're setting general configuration that applies to the entire test.
And percentage.
Yeah, go ahead.
As a plus sign does concatenation, I read somewhere percentage also does something, but can you explain?
Yeah, the percent sign is the default behavior, which means that we're going to choose a combination of things from everything in this directory. So if you go to there's a README in the QA directory that explains more about exactly what these different kinds of files do. So here's an example here with a simplified directory structure of a suite. So with the percent sign here, it means it's going to take form a matrix from all using one YAML file from each subdirectory. So we've got 4 different subdirectories, or 4 different files in this directory, A, B, C, and D. And for each test job, it's going to take one of each of those different facets.
Thanks.
Sure.
Josh, I had a question. If I'm like writing a Python script for testing some feature and I want to test out that script locally, the best way to run it would be using the CephFS test runner.
It would depend on what you're testing exactly, like what your Python script is doing.
Okay, what if I don't need to make any changes to the cluster, like just a single node V start should be okay?
In that case, I'd probably make it a work unit. Just put it in the work units directory.
Okay.
Because it could be any kind of script that runs against the cluster. It could be Python. It could be Go. It could even be C++. Well, maybe not Go, but I think we do actually run make in those directories too. So if you have something that needs some compilation, that can be done as well.
Okay.
I see there's a question from Matt in the chat about what makes the runner specific to CephFS at this point, and I don't think there's anything that's very specific to CephFS at this point. Patrick, correct me if I'm wrong, but I think it's fairly general since it's running manager and dashboard tests.
Yeah, I think just the name is there because when John Spray was working on this, it was just geared towards CephFS, but I believe it's been generalized. It should just probably be renamed at this point.
Any other questions at the moment? Okay. Well, I want to talk about a couple other kinds of tests briefly. So we also have this standalone test framework. This was originally used in MakeCheck years ago, but we took it out of there since the tests that use this tend to run for quite a long time. It's a kind of batch framework with a bunch of helper methods for setting up a cluster in different ways and running some more invasive testing on it. Things where you might want to interact with a particular OSD or particular PG in a certain environment. So this is kind of similar to the work units in the sense that it can be easily run from a vStart environment or within Teuthology. But it is kind of setting up these clusters in a very unique way that's not used by anything else. So at this point, I wouldn't recommend writing new tests in this format. There's a README file in the repository that describes how you can run it and locally, and how you can add them to the suites in general. The final kind of test I wanted to cover today was thrashing tests. So these cover a lot of different ground and are one of the areas that help us find the most bugs in Ceph. These are implemented in Teuthology with a few different tasks, which tend to have a similar kind of structure where they have a bunch of different ways that they manipulate the cluster, depending on which daemon you're talking about. It could be MDSs, Ps, and they let you kind of specify different weights for the different kinds of actions that they take. So if you want, you might want to, for example, really stress PD splitting behavior, and for that we have some configurations where you can do a whole bunch of PD splitting operations all the time, and not so much not so many other operations like taking OSDs in and out. Or you might want to run against an erasure coded pool and really stress for kind of recovery around below the minimum size. So you can change the configuration in terms of like how many OSDs you want to guarantee are still in the cluster, that sort of thing. But this is maybe a good time to look at the Teuthology tasks in a little bit more detail. So as I was mentioning earlier, for any of these tasks, you can find them in the Ceph repository for the Ceph specific pieces, either in the QA tasks directory, or for more common pieces that are more general, in the Teuthology tasks directory in the Teuthology repository. So if we look at, for example, the thrash OSDs task, you can see for a lot of the tasks, they're defined by a task method, which is decorated as a context manager. This simply means that they will have some kind of initial setup and then some kind of teardown at the end. And in their docstring, they'll describe the various kinds of options they have. So for the thrash OSDs, you can choose like how many OSDs to make sure are in the cluster, how much delay there is between doing different things to the cluster. A whole bunch of different options here, essentially, different ways you can affect the cluster and try to induce different kinds of behavior. An interesting one is the power cycle option, for example, which ends up using IPMI for all the bare metal hosts to directly or virtually pull the plug on the system and start it back up again. We have a specific suite that does this. We run on a little bit or less frequent basis, since in the past when we've run it too often, it tends to actually kill the hardware. But generally, these tasks will, in addition to listing out the configuration options, will also have a few examples. So giving a simple one here, where you have the Ceph task and then thrash OSDs with a few of these options changed from the defaults.
I had a quick question actually. So these tasks, these thrashing tests can be done for all the client level, client or at the client level as well, right? For RGW or for RBD, for example.
So I believe there's a thrashing for the mirror daemons, I think, for RBD mirroring. I'm not sure about RGW, if there's a similar sort of test for its daemons. Maybe if Matt's here, he would know.
What's the precise question?
Is there some kind of thrashing for RGW daemons?
I don't think so. I think it might be a gap.
So
Yeah,
do
good point.
the messenger failure injection work with RGW? That's something that works elsewhere, at least.
I'm not aware. I mean, if so, I haven't noticed it. But we don't have a particular, a thrash scenario specific to RGW that I know of. Specifically crafted to RGW daemons. How they assemble things, or other things. They don't currently have concepts like that. But as time goes on, we'll probably want to look more at that idea.
Yeah, the messenger failure injection and delay injection is something it's pretty generic. I think that could be certainly enabled without much work there, just by adding those configurations to suites. For RBD, there's like that RBD mirror thrash task that does similar things to the RBD mirror daemons. So this is actually a good example of like a new style task. Oh no, it's a little old style. So there's you'll see the original style of tasks was that they were defined using a task method or other methods that were context managers within a given module. There's also a newer style where you can inherit from a task class and implement some methods to represent the kind of setup, tear down, and active activity stage. In the old style, all the setup is everything before you get to this yield statement. Once you reach the yield, other tasks after this get run, and once they're done, and the Teuthology starts cleaning up, it unwinds the context managers, and each task's finally section is running in order to do any cleanup that's necessary. And in this case, like stop the thrasher and revert to finish. And there's another style with the object-oriented approach where you instead of using a context manager, you can make a subclass of this general task class and override a few of these methods. So it has it. So you have a set of method that's called before it executes. You have the begin method for the main functionality of the task. In the thrashing case, this would be empty. It's not doing anything in the during the begin phase. That's effectively the this would be used more for things that run in the foreground, like let's say the radius bench task to actually run the radius bench command, and then the end and tear down phases to clean up and restore it back to its original place. Nice thing about this object-oriented way of defining these is it does have some helper methods that make things a little bit easier. It has an apply overrides method, which is a common kind of structure that we use in a lot of tasks, where you can specify like these overrides at the top level of your configuration. So pretty much from any YAML file, you can add some overrides that would apply to any kind of to a lot of tasks configuration. So for example, we use this a lot to apply different kinds of Ceph configuration settings to the Ceph task, or to change the version that's being installed for the install task. But in general, it allows you to kind of very easily use the same kind of functionality there. An example of this new style task is the console log task in Teuthology, which sets up logging from the consoles of the machines and saving that log while the test is running. So it sets up by just setting up the data structures, and then when it begins, it starts collecting the logging. I should explain the concept of remotes here. So when Teuthology is working with these test nodes, it's usually accessing them via this interface in Teuthology called the orchestra library, which is kind of a wrapper around a Python SSH library. So you can run all kinds of commands over SSH, and the presents is these each machine is a remote. So we're kind of looping through each of the machines here, and for each one, we're got some console methods implemented to connect to the console and get the log from it. And whenever you're running something on the remote, it'll return a process object that you can save, and you can kill or wait for it to exit later. But by default, when you're running things, it'll be asynchronous using this kind of method. Looking at another kind of example, I mean, the exact task is a simple one. This is the task list that lets you kind of execute arbitrary commands on a given machine. So note that these all have the same kinds of two parameters: the context and the configuration. Context is kind of like a global context object that's passed through each task as it executes, and tasks can kind of store their own kind of extra configuration there. When like the Ceph or Ceph ADM task runs, they'll add their information about the running daemons and daemons from different clusters, since you can set up more than one cluster, to this context object. So that later tasks can refer to that and understand like what's the configuration for this daemon and for the Ceph.conf, or they can go and inspect that a particular cluster and operate on it the other cluster if they want to. But you can use this context object to kind of store state that you want to have accessible to later tasks as well. I think the RTW task is a good example of that, where it stashes away like things like the ports and addresses of the RTWs that it's setting up, but the later tasks that run tests against the RTW know where to find it. and the configuration that each task gets, that's the this section of the YAML. So everything below the task piece is going into that configuration variable. So in this case, this would be a dictionary where the key client.a and a value, which is a list of 2 strings. So if you look at the implementation of this task, we're just logging what we're going to do, making sure that our configuration is dictionary as expected. If we don't have a particular role specified to run this, if we can say all to run this command on every role. Then we loop through the roles in our configuration and the list of commands to execute on them. And this is a pretty common pattern you'll see a lot, where we look at the context.cluster object, which represents the nodes in the cluster and the daemons that are running on them, which is generated from the roles in your test configuration. And then since we're looking at trying to execute these commands just on a particular role, like say monitor mon.a or osd.0, we're going to filter that down to just monitor.a, for example, and get their remote machines that represent just that one monitor. And then run the command on that single remote. Passing in the test directory as an environment variable in case we need to use that within the command, and then just passing the full command along to bash directly. And since this task doesn't do anything that needs any kind of teardown or anything, it's just executing some commands. This one is actually not marked as a context manager, so it doesn't have any kind of teardown section. So that's a brief look at that's a kind of structure of tasks within Teuthology. There are a lot of different ones here. I think there's a brief guide in the Teuthology documentation linked here, which kind of describes a few of the common tasks that we have and some of the common ways that they can be used. But I think some of the best way to learn about this is to look at what's being used in actual suites and examining what kind of tasks are being used and looking at their documentation in the tasks implementation file. I guess one other thing worth noting is that we saw like the ceph.restart task used earlier in the upgrade suites, things like that. That when you see like a dot in the task name, that means it's a sub. It's another method within the ceph task. So the ceph task would have a restart method that also is a context manager and implements that ceph.restart functionality. Taking a brief look at that. You can see it's a context manager as well. So that means that this function can be referred to in YAML files. For an example, saying ceph.restart and then specifying a list of daemons. We're coming up on the end of the time pretty soon, so I want to leave some more time for questions. Any more questions right now? Okay. Well, looks like we probably don't have a lot of time to cover the rest of this, so we'll continue this topic a little bit next week, looking at how to actually run Teuthology while you're developing a test, and perhaps a little bit more, going into a little bit more depth about what kinds of code you need to write, or what kinds of options you have when you are writing a new test in Teuthology, in a task in particular. So thanks everybody for joining, and we'll see you next week. Feel free to send any questions you have you think of later. I'm always happy to help.